right, I think it's time to get started. Good afternoon. My name is Mike Niehaus. I am here this afternoon to talk about really the size challenges with Windows 10. How do you deal with the larger updates and upgrades that we're deploying as part of Windows as a Service? I think a lot of you probably went to my previous session where we talked about Windows as a Service. First, let's start off with a blank screen. That doesn't work so well. Let's try an actual slide. Let's start off with a recap of one of the topics from that previous session, really talking about the changes that were made with how we build, deploy, and service Windows. From a building perspective, with the insider preview process, we can provide new capabilities about every month. With the deployment process and the servicing process, we can update Windows using monthly cumulative updates, as well as feature updates that deploy about twice per year. So we want to get into that rhythm of pushing out monthly updates as well as the every 6 month or so feature updates. So size comes in when we start talking then about the quality updates, because these monthly updates are fully cumulative. Each month we add stuff to them, and as a result, the packages keep getting bigger. The feature updates start off big, because effectively they're a brand new operating system release, a bundle of all the new operating system files that needs to be deployed out to all the existing Windows 10 clients. So from a quality update perspective, these start off small with each update, with each Windows release, and then they grow over time. The feature update size is pretty much consistent for each release, but you do have to deal with this about twice per year as we release these. So when we look at these from a size perspective over time with feature updates, no big surprise, they don't vary by much. We have about a 3.5 gig payload for each one of these when we release them. So if you had a PC that was deployed originally on Windows 10 1507, you then deployed another 3.5 gig update out to it to move to 1511, another 3.5 gig to get to 1607, another 3.5 gig to get to the next one that will come out in 2017. Like we announced on a blog when the anniversary update shipped, we won't have another Windows 10 release in 2016. The next one is in 2017. But each one of these has a full set of operating system media effectively bundled inside an update that gets pushed out to every PC. So this is what generally gets people worked up initially. How am I going to push out 3.5 gig to every PC on my network twice per year? I'm not sure that my network can handle that. Well, at least that's what they think their biggest problem is until they look at this particular picture, which is looking at the monthly update sizes. I mean, we start off nice and small. Like with 1511, we started off with something that was well under 100 meg, and each month we continue to get bigger. So over time, we've gotten to the point where the September update was right at about a gigabyte. And based on the trend so far, we think that it will continue to grow over time. So if you look at just that size, you start to think about it being a little bit different than the problem that you thought when you look at it over a period of about 2 years. If you look at this from a 2-year perspective, 1 gigabyte per month on average for those monthly updates over a period of 24 months is 24 gig of traffic per PC. Divide that by the number of days that you would typically be distributing that traffic. For most of you, when you're deploying new security updates, you want to deploy that within days. So let's say you do 3 days for each one of those to get those updates deployed throughout your organization. That's 36 days to deploy 24 gigabytes worth of traffic. Compare that to those 3.5 gig feature updates. So in 24 months, maybe we have 4 of those, averaging about once every 6 months. Each one is about 3.5 gig. So that's about 14 gig of traffic per PC. But it's pretty much spread equally across those 24 months because we're not in any big rush to get these feature updates deployed to each PC. So when you divide out, when you do the math on that, doing the 3.5 gig deployments really isn't that bad compared to those monthly updates. So, well, I didn't probably make you feel any better. I just kind of shifted you away from one problem into a different problem. So what do we do about that? Well, fortunately, we have a bunch of different technologies that we can use to really reduce the impact of both of these sizes. The first one worth mentioning is Express Updates. We have this ability with Express Updates to only download the pieces that have changed from the previous month's quality update. So if we only have 100 megabytes worth of new fixes added to the cumulative update that we released, we only have to download 100 meg, not the full gigabyte that's in the package. That's the easiest one. We also have peer-to-peer distribution capabilities, because if we're going to be pushing around large quantities of data, we want to do it efficiently. Efficiently isn't having thousands of clients connected back to a server in the data center and then having each one download it to their local PC. Instead, it's much better to do peer-to-peer distribution, where we can have one PC on each subnet, download the content, and then start sharing it to other PCs on that network. So as a result, we're basically doing fan-out distribution. We're removing the bottleneck from the data center and the distribution points inside the data center and pushing it out to the edges of the network where there's a lot more capacity. We can also put in place bandwidth throttling. Most of the downloads that we're talking about are transferred using bits, which does background transfers of all of this content. We can put policies in place on the PC to say, trickle this down in the background. We're not in any hurry to get the content there. We just want to make sure it eventually gets there. So let's do this in a way that doesn't impact the network too severely. And then we can also add in scheduling when we're talking about products like System Center Configuration Manager that have advanced distribution capabilities to let you specify exactly when I want to distribute the content from site to site, when I want to distribute the content from a server to the local client, and then add into that the server to client download times to be able to very accurately control when each PC begins downloading this content. When we look at feature updates, we have the same basic technologies that we can use. The only difference would be express packages. Today, we can't do anything with the feature updates to do any type of delta. I mean, we are working on that, but that will come at a later point in time. So for right now, you do need to get the full 3.5 gig to each client, but certainly using peer-to-peer distribution is something that works really well. Using bandwidth throttling to make sure that we don't have hundreds of PCs all frantically trying to download the content at once works well, and doing scheduled distribution works out pretty well as well. But let's walk through each one of those just so that we make sure that we understand how these work in the bigger picture. First, with the express update packages. This is something that's been around for ages. I mean, it was implemented in WSUS 3.0 and it's been around for probably even longer than that. My knowledge doesn't go back any farther than that, but it's basically a mechanism where we can package up the updates so that we know exactly where the individual components are inside of the big cab files that get downloaded by WSUS to distribute these. Since we know exactly where each component is, we don't need to grab the whole update if we know that we only need a certain number of components. So the first month we can release an update that has 5 different components in it. The next month, one of those or two of those updates, two of those components might get replaced by 3 new components. So as a result, the client can look at this and say, I really only need to download 3 new components. If you look at that from that 1 gigabyte perspective, instead of downloading a gigabyte, it only needs to download maybe 100 to 150 meg. It's going to vary by month depending on the particular components that were updated, but it can be smart about it. The way it goes about doing that is actually doing a byte range transfer. Instead of requesting the whole file, it can just request chunks of it and say, I want this chunk, and this chunk. And once it gets those chunks, it can then do the installation of those components just using those pieces. So if you're using Windows Update directly or Windows Update for Business, where your PCs point to the internet to get all their updates, this happens automatically. So for the bulk of the 400 plus million PCs running Windows 10 that point directly to the internet to get their updates, this happens automatically. they always figure out what new components are needed, and they just download those new components. So they're only downloading roughly about 100 to 150 meg per month. But for PCs that are updated using WSUS, Config Manager, and third-party updating tools, you have to make sure that this is enabled and supported. In the case of WSUS, to enable it, you just need to go into the WSUS configuration and check a box. In the case of Config Manager and third-party patching tools, unfortunately it's not yet supported because Windows hasn't disclosed to Config Manager and to these third-party tools exactly how to go about doing that. So we are working on some updates to support that. But if you're using WSUS today, really easy to go in and enable this. The only downside is that you need more disk space on your WSUS server. Enabling the Express Update packages will probably double, triple, quadruple the amount of disk space required on your server because it will maintain a copy of the non-Express updates as well as a copy of the update in Express format for every update that your server has ever downloaded for Windows 7, Windows 8, Windows 8.1, Windows 10, etc. So hopefully you've done your homework on estimating the amount of disk space required on your WSUS servers, and you have sufficient space to hold these. But once you turn that on, you'll see an immediate reduction in the amount of network traffic generated by your Windows 10 clients pulling updates. This also will be useful with the changes that we've recently made for Windows 7 and Windows 8.1. If you followed the discussions there, we've moved to a model where we release two different things every month. We release a security-only update as well as a roll-up. That roll-up is cumulative, so over time it grows like the Windows 10 updates. It would benefit from Express updates as well. So if you're the type that currently deploys all patches to Windows 7 and Windows 8.1, you'll want to do this as well now that we're doing the roll-up updates for Windows 7 and 8.1. But definitely for Windows 10, because otherwise you're going to have your PCs downloading the full update every month. When we look at peer-to-peer distribution, we've got options, several options, but the benefits really are the goal with each of these is the same. We want to make sure that we can have a small number of PCs on each network segment, grab the content and hold on to it, and then provide that content out to the other servers for them to consume it. In the case of WSUS and Config Manager, they can use branch cache. Branch cache is another one of those features that's been in Windows for quite a while. It works in a variety of different modes and has a whole bunch of different capabilities, but all we really care about from this perspective is that it automatically caches and shares all bits downloads. Bits downloads are used by WSUS for every update that's downloaded from the WSUS server. It's used by Config Manager for all content downloaded from the Config Manager server. And as they continue to enhance Config Manager to be more branch cache and network aware, they've even gotten to the point now where the policy downloads coming from the server use branch cache as well. So they're constantly tweaking Config Manager to make sure that they have the least impact on the network as possible just by turning on these operating system components. You get to a point where as the content is distributed, as long as you do it somewhat smartly, the efficiency that you can get out of this is about 90%. So some PCs are going to need to pull the content from the server initially to seed the machines. And in some cases, maybe there isn't a peer available, or a chosen peer is too busy, or for whatever reason, the client then decides to go back to the server. So you probably aren't going to get to 100%, but you can get pretty close as the content gets seeded to more and more clients on the network. You can do this very badly if you're not careful about it. Imagine a scenario where you've got Config Manager where you're deploying, say, the monthly update to 10,000 PCs, and you set a deployment that says start at midnight, and it is going to be mandatory as soon as possible after that. So as a result, all the PCs get the policy ahead of time. They all sit and wait patiently for midnight to happen, and then they all frantically start downloading the entire update. So you've got all of these PCs that are suddenly sending out broadcasts to other PCs on the same network segment saying, I need to download this right away. Does anyone else have it? And they all answer back, no, but I'm in the process of downloading it. They don't back off. They don't slow down and say, okay, well, you're downloading it, so I'm going to wait until you've got it done. No, they're all going to try to grab that content at once. So you have to be a little bit more careful about this when you do your deployments to say, start whenever, start now, but begin the actual installation at some future date. This normal randomness of clients checking for new policy from the server when they see that start now means that they'll start downloading at different points in time. And then Branch Cache is able to cache the content as it's being downloaded so that it's then available for other clients to grab it. So Branch Cache works out pretty well. We'll take a look at that in a couple of minutes just to see what that looks like. We also have another technology called delivery optimization. This is tied into the Windows Update service. So as a client scans for updates and figures out what it needs to install, instead of just directly downloading it from the internet, it will first ask the delivery optimization service on the internet, are there any peers near me that have already downloaded this that can provide the bits to me instead? So in this case, the client talks to the server up in the cloud. The server in the cloud says, oh, here's a list of 100 of them that are on your same network segment that have already downloaded this content. Grab the content you want from one of those peers instead. So it avoids those PCs grabbing the content from the internet and lets them share locally. There are a variety of modes that this can operate in, so you can do some configuration on that. We'll talk about that in a little bit. One of the things that isn't understood, and most people probably haven't noticed yet, is this also works with WSUS. So you can have a PC that's pointed to WSUS for updates. It scans to figure out what it needs. It decides, I need this update, but before it starts to download it from the WSUS server, it reaches out to the delivery optimization service in the cloud and does the same thing. I need to download this particular update from WSUS, but if you've got any other peers available for me on the same network segment, give me a list and I'll try to get it from one of those instead. So we've got those two technologies. The Config Manager team's also working on a third, because you can never have too many choices. They're building into the Config Manager client a peer-to-peer technology. They initially delivered this called peer caching as part of, I think it was in Config Manager 2012 R2, but it was only used in Windows PE and only for operating system deployment. Now they're expanding that to all Config Manager content to enable that to be used for updates and feature updates and all kinds of other things. So you will have a third choice with that. So at that point it becomes a question of, well, which one do you want to implement? Do you want Branch Cache, which works within a subnet and caches chunks of content? Do you want to use delivery optimization, which requires reaching out to the internet? Do you want to use Config Manager, which can span subnet boundaries, but requires that the complete content be downloaded first within the Config Manager cache location on each client? So you do get into a case of picking and choosing based on the requirements that you're looking to fulfill. So we will be publishing more guidance and help around that as we get deeper into this. But for right now, we have published at aka.ms/WAAS, Windows as a Service, step-by-step guidance that explains how to implement Branch Cache, how to configure delivery optimization. Since it's a cloud service, there's nothing that you need to do other than configuring it, and really trying to explain what needs to be done to put these into practice. Bit throttling is another thing that generally you would want to use, especially if you're combining that, especially if you're using something like Branch Cache as well. Because you can configure different policies for whether the content is being downloaded from the server versus whether it's being downloaded from a peer. So if it's being downloaded from the server, put a cap on the amount of bandwidth that can be consumed. So maybe you put a 1 megabit cap on the content to slow those downloads down, which allows more clients to get the content cached, and then it can begin sharing after that. But for peer-to-peer sharing, that can be done at full speed. So don't set the policy to restrict that. Allow the content to be slowly trickled down from the server, but as soon as it is and it's cached on the client, even at a 64K chunk level, it can then start sharing that with other PCs that are downloading that content. When we look at scheduling, this is really where we get into the config manager space. Config manager has all kinds of capabilities around scheduling when content is distributed, scheduling when it's deployed to clients, and scheduling how the clients actually pull it down from the distribution server. So we could probably do an hour-long session just on the config manager capabilities here, but it is something to look at as far as controlling how this content is distributed throughout your network. So let's dig into delivery optimization first. Delivery optimization, how many of you see my blog talking about delivery optimization? Just out of curiosity, a few of you. It's been kind of one of these mystery services because the documentation that we had published until recently wasn't terribly complete. But we have published a lot more in the last couple of months that kind of open up the curtains and show you what's going on behind the scenes. But the basic idea is exactly how I described it before. A client has decided that it needs an update, and then it asks the delivery optimization service, are there some peers available for me to grab that before I try to download it from the internet or from a WSUS server? So we provided some policies to control that. We can specify how we want to group PCs. By default, the behavior of delivery optimization varies by SKU. If you're talking about a home SKU, it looks at any PC that's accessible on whatever internet connection you have as a potential peer. If you're using a higher SKU, like the enterprise SKU, it would only consider PCs on the same LAN, on the same network segment. But there are other modes that you can configure this in as well to group PCs yourself. What you want to avoid are scenarios where a PC in Auckland might decide to share content via peer-to-peer with a PC in New York City. That's probably not a good idea because it would be better off downloading the content directly from the internet. So there are some configuration options. There are some a variety of group policy settings that you can put in place to tweak this, but once it's implemented, it's kind of a set it and forget it type of thing where it just automatically checks with the service and begins downloading that content. So let me pull up the shortest table ever. Let's look at the policies that are available there. When we look at delivery optimization, the policies to enable it can be found under Windows Components, Delivery Optimization. The only thing that you probably want to configure is a download mode. And the download mode values depend on what other technologies you might want to use. If you're not using any other caching mechanisms, you probably want to leave it at LAN or group. LAN basically says I want to consider any other PCs within the same local area network as available clients for sharing peer-to-peer. Group takes it a little bit further depending on the release that you're running. If you're running Windows 10, 15, 11, group means any PC where I've configured a separate group ID policy. If you're running Windows 10, 16, 07, group actually uses the Active Directory site as a boundary for the group location. So if you're running 1607 or later and configure it for group, it's only going to share within that AD site, which is convenient. But at the very least, leave it configured or configure it for LAN. And you can consider some of the other settings, but they're more small tweaks, like I want to restrict the clients that can serve as providers for the peers. I want to limit the amount of bandwidth that can be consumed. So lots of additional tweaks that you can put in place. Now, if you looked at the policy the way I had it configured initially, I actually had it set to simple. Simple here means download with no peering, delivery optimization using HTTP, and does not attempt to contact the delivery optimization cloud service. Effectively, that's saying turn off delivery optimization because I don't want to use it. If I happen to be using branch cache and I wanted to use branch cache instead of delivery optimization, I would configure it for bypass. In bypass, I'm saying don't use delivery optimization, use bits instead. It really doesn't make sense to have both bits and branch cache running, so if you implement branch cache, you may want to configure the download mode exactly like that to bypass it. So that's really all the configuration that's there for delivery optimization. The biggest challenge really is figuring out, did it do any good? And that's something that we're working on for the next feature update, to add additional diagnostics to be able to show you this much content came from the internet, this much content came from peers. In the meantime, it is possible to take the log files for delivery optimization, which you can find in the Windows Logs DO SVC folder, and format them. So it's a messy process because you need a trace FMT, trace formatting tool from the Windows SDK in order to do it. And it requires that it pull down the symbols for this particular operating system to do the formatting, but you can point it at a delivery optimization log file, the ETL trace file, and it will format that into a text file where you can then see everything that's going on with the delivery optimization service. So if you ever happen to run a network trace and you started seeing network access to this do.dsp.mp.microsoft.com location, or the IP addresses that resolves to, that is the delivery optimization service, and my client PC, which is pointing directly to Windows Update for Business, is starting to get its updates from there. So it will show information about the clients, the peers that it's trying to talk to, and you can kind of follow along the process there to see what's going on. It's not the most friendly log to look at, which is why we're continuing to work on that and to provide probably some PowerShell commandlets to simplify that in the future. But that's delivery optimization. The next one in the list really would be branch cache, which is available in Windows 10 Enterprise as well as Windows 10 Pro. Some people think that it's not available in the Pro SKU. Well, a subset of it's available in the Pro SKU. The subset that we care about, which is the ability to download using bits. So if you have Windows 10 Pro, Enterprise, or Education, you just need to turn it on, which is a simple group policy to turn on branch cache, put it into distributed cache mode because we don't want to manage any dedicated machines to service as hosts, and then set some firewall rules that allow the peer-to-peer sharing to be done. But once that's done, all the bits transfers are going to begin to use this to transfer content. So if we look at my same server over here, I've enabled branch cache on this machine, first by setting some firewall rules to enable branch cache content retrieval. The hosted cache I didn't actually need, but it was part of the normal rule set, and the peer discovery rule needed to be configured as well. Once those are set, then you just need to set the branch cache policies to turn on branch cache, simple, enable it, and to set it into distributed mode. So we enable that as well. Once that's done, all of the content being distributed via bits, which would include all WSUS traffic and all config manager traffic, will begin to use it. It's kind of the same scenario though. How do you know that it's doing any good, which has been the biggest challenge for most people who are looking at these peer-to-peer sharing capabilities? How do you see what's actually being distributed peer-to-peer? With Windows 10, we enhanced branch cache and bits to create an event log entry for every bits transfer, which indicates what amount of the traffic came from the server versus what amount came from the client. And with that information, we've seen that there are people building dashboards for doing this. First, the config manager team is building this into the product. It's still in technical preview. But with Config Manager, they can show you what percentage of the traffic came directly from the DP versus what came from using branch cache and peer-to-peer. But there are also some third parties out there like Two Pint Software that have created an add-on dashboard for Config Manager or even for standalone WSUS environments where they can collect those event log entries and look at the same type of thing. What efficiency am I getting? What percentage of the content came from a server versus a client? So it's really useful to be able to see the benefits of branch cache so that you know that it's not just some mysterious service that I've turned on my network. I can actually see that it's doing some good. So if we look at that from first from a Config Manager perspective, we can see the dashboard as it sits today. I haven't had it enabled for very long, so it's only helped out in a few cases so far, but we can just see at a glance that 16.5% of my network traffic has come via branch cache, and right now still 83% has come from the server. But it will continue to collect this information over time, and as they work on their peer caching capabilities, it'll begin to show that as mixed into here as well. If we look at this from, say, a WSUS environment perspective, I've got all of my clients here configured for branch cache, and I'm distributing updates approved from my WSUS server. So remember before I said that there were event log entries created for each bits transfer. All we need to do is grab them. So via a simple PowerShell script, I can call getWhenEvent, pass it the name of a computer. So I've got 10 computers out there that I use to test this. Grabbing from the bits log any event ID 4s, and then looking at the properties of that, I can see exactly what's happened on all of the bits transfers on each of those PCs. So that's the sort of information that those dashboards are showing you. It's really looking at these results and graphing them for you. So if we look at some of these PCs, I can see that, okay, today it downloaded a 7 meg update and 100% of it was transferred via peer-to-peer. Here we can see a larger update. That one was like 1.6 gig and it downloaded that's 162 megabytes and it downloaded 73 of it using peer-to-peer. So we're not seeing 100%, which is just kind of the randomness of my 10 PCs and when they started grabbing the content, but it's pretty good overall. If we were to take that data, put it into a spreadsheet and total it all up, it would be roughly about 90% of the traffic being shared peer-to-peer instead of pulling it from the server. So that's the benefits of branch cache really being shown as part of the updating process where we can download that content from the server or from a peer. So if we look at the different tools that are in use then, we can see different capabilities for different tools, like Express Package Support. That's the biggest one for the monthly updates. Today we support that with Windows Update for Business, and WSUS. It's optional in WSUS. It's something that you need to turn on. If you wanted to turn it on, it's a really easy thing to do. If we go into WSUS, into the options, under, I think it's Update Files and Languages, we have to check the box that says Download Express Installation Files. Once you do that, yes, it's going to download larger updates and it's going to increase download times to get these from the internet, but overall it's going to be much, much better on the network traffic to the client PCs. As I mentioned before, Config Manager doesn't support that yet because Windows doesn't support that yet for other products. So we are working on enhancing that. The Config Manager team has already said that they'll add support in their upcoming Config Manager current branch release, the 16.10 release that they'll be coming out with very soon. So that's the Config Manager side of it. Then we also need to update the Windows client operating systems to enable that as well. We're still working on the exact time frame for that. We know that it will probably be sometime early next year. The exact time is still being worked on. It's just a question of when they can get that work done. For third-party tools, they need that same support. They need the same thing that Config Manager needs in order to support Express updates. So as soon as we get the capabilities working with Config Manager, will publish documentation that the third-party tools can use to do the same thing. Peer-to-peer, Windows Update does it using delivery optimization. Windows Update for Business does it using delivery optimization. WSUS gives you the choice between branch cache and delivery optimization. By default, delivery optimization is on. You can turn that off or put it into bypass mode if you're planning to use branch cache. Config Manager right now supports branch cache, and they're adding support for their own peer-to-peer. Third-party tools generally offer some sort of peer-to-peer capability as part of a management tool, but you'd have to talk to the provider of those tools to see exactly what the capabilities are there. Behind the scenes right now, all of these use bits to do downloading, so you can set bits policies to restrict the rate that this content is downloaded. As far as scheduled distribution, Config Manager does a really good job of that. And Config Manager also has this ability to hook in alternate content providers. So you can have a third-party product that hooks into Config Manager that takes over the content distribution capability. There are two of them that I'm aware of that do that already. One is from 1E Software called Nomad, and the other one is Adaptiva OneSite. These are basically add-ons to Config Manager that do lots of advanced distribution capabilities to distribute content throughout your network. So you can get by with delivery optimization and branch cache and Config Manager peer-to-peer. They do require some care for different scenarios, as I had mentioned as we were going through, but with these alternate content providers, they're really designed to be just install and deploy and don't have to worry about that they take care of all of those details to make sure that the content is distributed as efficiently as possible. So if we look at the individual solutions, just to kind of summarize what each one can do, Windows Update for Business does support Express, so it will download the smaller content size each month. It does support delivery optimization for peer-to-peer transfer. You can use bits throttling to restrict the download speed. And there's a policy called active hours that lets you determine when the actual update installation happens. Generally, it will download the content in advance of that, and then when the active hour time expires, like in my case, my active hours are set through 11 p.m., it will then install the update after 11 p.m. and reboot my PC. If we look at Windows Server Update Services, WSUS, WSUS supports Express. You just need to go in and check the box to enable it. It supports both delivery optimization and branch cache. You probably don't want to use both of them together, so if you're going to use branch cache, make sure you put delivery optimization into bypass mode. And it supports active hours because really it's the Windows Update agent that's taking care of doing the actual installation. It just pulls the content from the WSUS server. You can configure that active hours time range via group policy if you want, or you can allow the user to set it themselves to whatever hours they're typically working. I forget what the default is, but something like 8 to 5, and outside of that is considered a time that's available to install these updates. For those 3.5 gig updates, the feature updates that I talked about before, those are available through Windows Update for Business, and WSUS, but only for the current branch and current branch for business. If you're dealing with LTSB, if you've deployed Windows 10 Enterprise LTSB 2015 or 2016, we'll never offer feature updates through Windows Update for Business, or WSUS for those. So to upgrade from one LTSB release to another, which is kind of a strange thing to do anyway, because you basically said you want a device that never changes and then you want to upgrade it to the next release. But if you wanted to do that type of upgrade, you had to do it from media. So if you've deployed Windows 10 Enterprise LTSB 2015 and you want to upgrade to 2016, go out to the Volume License Service Center, download the ISO for LTSB 2016, and then upgrade using setup.exe/auto upgrade, or using a Config Manager task sequence. Behind the scenes, that's all Config Manager task sequence does. It just runs setup.exe with those command line switches to automate the upgrade process. System Center Configuration Manager 2000 or 1602 or later is required to support Windows 10 1607. That's their basic support policy, is they'll always support their current release and an N-1 release with a new Windows 10 release. So when 1607 came out, they had just released their Config Manager 1606 release, which added support for new Windows 10 features, but they have compatibility support in their 1602 release. In order to support patching and feature updates, both with Config Manager, you do need to be running WSUS 4.0 as your Config Manager SUP, which does mean your servers need to be running Windows Server 2012 R2 or above, because WSUS 3.0 doesn't support feature updates, and Config Manager has some restrictions on mixing and matching operating systems and WSUS server versions versus the site server version. So pay attention if you're not yet running at least Windows Server 2012 on your Config Manager servers. But once you get the necessary Config Manager version in place, at least 1602, then you can use Windows 10 servicing plans to do the deployment, or you can use task sequences if you want. But in either case, it supports branch cache and peer caching for content distribution. Peer caching currently only in the technical previews. It supports scheduled maintenance windows, deployment scheduling, distribution scheduling from site to site, so lots of capabilities there to take advantage of. And again, the Express updates is something that they're planning to have in the 1610 update, which should come out sometime next month, but it will require additional Windows support in order to fully support that. From a futures perspective, we've touched on a couple of these as we've gone through. We need to enable Express updates for every product that wants to deploy updates to all the different types of machines. We will do that in Config Manager first, and then we'll expand that out for third parties to implement that as well. That could take some time for them to implement, depending on exactly how they're doing their patching today. The problem that Config Manager runs into today is they download the entire update to the client and then tell the client, please install from this local content. That defeats the purpose of Express updates. So in order for Express updates to work, Config Manager has to re-architect to instead tell the Windows Update agent on the PC, please install the update, and I've got it over here on my distribution point. So that's the change that Config Manager is making today to get ready for the APIs to be added into Windows 10 in the future. So that's coming for Express updates. For the Delta upgrades, this is to support the feature upgrades, the feature updates that we talked about before, those 3.5 gigabyte packages. We want to be able to be a little bit smarter about that and only download the pieces that have changed. The challenge, though, is there are lots of changes from one feature update to the next. So in Windows 10 1607 compared to Windows 10 1511, pretty much every binary in the operating system was updated. So the things that aren't updated are things like fonts and bitmaps and sound files and things like that. So when we actually look at a delta between the two operating system versions, it's a pretty sizable delta. But we do want to go through the effort of shrinking that as much as we can. We're still working out exactly how much we think that we can reduce that down, but it's probably going to be in the neighborhood of about a gigabyte reduction. So instead of doing a 3.5 gig transfer, maybe we can just do a 2.5 gig transfer. So it goes from big to slightly less big, but it's still a big package that needs to be distributed through your network. So plan accordingly, make sure that you can get a peer-to-peer technology in place to handle that, and look at some of the other techniques that we talked about in here as well. Now that will require changes to the deployment tools, the patching tools, and the management tools that you're using today to deploy feature updates, because they'll need to understand how to deploy these new updates. So don't be surprised to see that there's a need for a hot fix for WSUS and a new Config Manager release and updates to the third-party management tools in order to support this new Delta upgrade technology that'll be coming probably later in 2017. Config Manager peer caching, that's been in their technical preview now for several months. They basically have an ongoing series of technical preview releases. Every month they come out with a new technical preview. Sometimes they add new features. Sometimes those features end up getting released as part of the next current branch release of Config Manager. So that peer caching capability has been in the technical preview for a while, but it hasn't yet made it into an actual release. I don't think it's going to make it into their November release as well, but there's always a chance. But it might take them a while to work out the kinks for that to make sure that that's working really well before it becomes part of the production stable client release. But in the meantime, you can try it out in their technical preview builds. Hopefully you've got a lab environment set up where you can install that just to try out the new capabilities as they deliver them. So we published a lot of content around this fairly recently. If you go to aka.ms/WAAS, Windows as a Service, that actually takes you to the top of the tree that contains all these different pieces of information. But we've published details on how to configure delivery optimization and described some of the common scenarios, like I'm using WSUS and branch cache and want to turn off delivery optimization. Well, here's what you would need to go through for that. I'm just using Windows Update for Business. Well, then here's how you would want to configure that. So we've walked through those common scenarios and tried to simplify the deployment guidance as much as possible. Same thing for branch cache. We've had branch cache deployment guidance out there for ages, but that branch cache deployment documentation assumed you were going to use it for branches. Well, here we're talking about using it in branches, sure, but also within big offices. Because even within a big office, we want to use branch cache to fan out the content to the edges of the network. So a lot of the deployment guidance talked about how to do hosted caches and how to deploy to certain machines in an office to dedicate them as cache devices so that you didn't need to have servers in each location and all that fun stuff. Well, we're not trying to do anything that complicated. We're just trying to enable a simple fan-out distribution using a distributed cache mode. So we can greatly simplify that deployment guidance down to just a couple of pages. Go in and set the firewall rules that we looked at before, turn on branch cache, and turn it into distributed cache mode, and go. That's all you need to do. In the case of WSUS and Config Manager, there is an additional step. You need to enable the branch cache component on the server side, which is what basically enables IIS to do the rest of the work. We then also talk about some more advanced scenarios that you could do. Like in the case of Windows Server 2012 R2 in 2016, there's a disk deduplication feature. That disk deduplication feature just eliminates all the duplicate files and can significantly reduce the amount of disk space that your server consumes. Coincidentally, it does that by hashing the content and figuring out what chunks of content are the same at different places on the disk. That's exactly what branch cache does when it's distributing content to the client. So you can enable the disk deduplication on the server, and that actually pre-calculates the branch cache hashes for the content before it gets distributed down to the client. So there are some more advanced scenarios like that that are described in the documentation to make branch cache more efficient, but because the server doesn't need to do any duplicate hashing calculations for the content that it's distributing. But all of that's covered in the branch cache documentation that we published. We've documented the step-by-steps on how to set up Windows Update for Business, how to create your own rings, how to target different policies to those rings, how to do the same thing with WSUS, how to create computer groups and policies that target computers into those groups, and also how to do the Config Manager deployments, whether you're using task sequences or doing the Windows 10 servicing capabilities, but combining those with branch cache to get the efficient fan-out distribution for all of that content. So with that, any questions around the different size challenges, peer-to-peer capabilities, or any of the other things that we talked about in the session? course, in the back row.
Yeah, I was just wondering if the SCCM client cache is involved in these larger packages. So do we need to set a larger SCCM client cache?
In the case of, yeah, so for the client caching with Config Manager, both the updating mechanism, the quality updates as they're distributed every month, the feature updates as they're delivered every 6 months, those both use the Config Manager client cache. So if you don't have that configured to handle at least a 3.5 gigabyte package, then yeah, that will quickly present itself as a problem when all the clients report back that their cache size isn't big enough to download the content. So generally, I would suggest a cache size something more like 10 gig or more, so that there's enough space to hold the last few cumulative updates, as well as the latest feature update, plus enough space for the other stuff that you might be distributing. That'll become especially important as you get into the Config Manager peer-to-peer caching, because if the content ages out of the client cache because there wasn't enough room to keep it around any longer, then it can't be shared with any other Config Manager clients via the Config Manager peer-to-peer. So there's some advantage of making it bigger to be able to hold more of that stuff.
Are there any tips you want to put on the whiteboard when you meet with the security team and the same person you meet with in security teams to turn on network isolation for your clients?
They want to turn on network isolation as part of the patching process?
Well, not regardless of the protection process, but obviously to do that, you get one goes out the window.
It depends on the peer-to-peer mechanism. So if you look at branch cache works by doing segment broadcasts. It'll send out a broadcast to all the clients on the same subnet. If they have switches in place and every PC is connected to a switch, they could filter out that broadcast traffic and prevent it from being seen by any of the other nodes on that subnet, and as a result, prevent branch cache from working at all. If you have hubs or other non-interfering switches that just send all the broadcast to all the PCs on that subnet, then branch cache works just fine. So there, you could run into some issues like that. In the case of delivery optimization, though, there's no broadcasts involved. It's client talking to an internet service, that internet service saying, here's a list of PCs for you to try to talk to by IP address. It sends that list back down to the client, and then the client tries to connect to each of those directly. Assuming they haven't done anything weird, the client should be able to talk to one another in order for that to actually work. Then you just have to worry about the client side group policy type firewall settings. If you're using delivery optimization with the Windows firewall, it'll open those ports automatically. If you're using a third-party firewall, you may need to open those yourself. In the Config Manager peer caching case, it's very similar to delivery optimization, but using the management point. So the client would ask the management point, I need this particular content. Should I get it from the server, or can you provide me a list of clients that I can talk to instead? And then it'll do an HTTP transfer from one of those other client PCs. So again, as long as one of those clients is accessible over the network via direct HTTP type request, potentially on a different port, as long as they don't block that, then it should work out okay. So it is definitely good to talk to your networking people to make sure that they're aware of what's going on here. They will probably like the idea of pushing the network traffic away from the data center. They probably will raise some concerns about the edges of the network getting saturated, especially on the wireless side. Imagine that you've got peer-to-peer working perfectly, and you've got 1,000 clients connected to a wireless access point, and they all suddenly start transferring 3.5 gig between each other. That wireless access point might melt down because it's just going to be overloaded with all those clients talking to each other. So you may want to reassure them that, oh, we'll put in the bits transfer restrictions to keep it to a low hum rather than completely saturating the network.
Yeah, Windows 7 machines are rolling out updates the same way now, using the quality updates and security updates and the cumulative updates. Do you need WSUS4 for that?
For Windows 7 and Windows 8.1, you never need WSUS4. WSUS3 is fine. You may want to enable the express support now that we're doing the roll-up updates every month, but other than that, there's no version concerns with Windows 7 or 8.1.
What about servers?
Same thing with servers. You would need WSUS4 to support the,
Windows 12.
actually no, you never need WSUS4 for servers. Servers are all LTSB effectively at this point. So Windows Server 2016, you could never deploy a feature update to. Monthly patches for any server release from 2008 all the way up through 2016 will work fine with WSUS 3.0 and above. So you're good there.
I enabled Express packages last week, and it went out and downloaded a shitload of
Right,
new
'cause
packages.
It
which-
goes and
yeah,
grabs
yeah, yeah, I
updates
was
for everything you've ever approved.
Then I looked at the approved updates, and they said the download approved but not downloaded yet, and they stayed in that state and didn't get distributed. Any reason for that?
My guess is that there was just that much of a backlog of downloading the content that until it had completed everything in the backlog, it wasn't going to get to those particular items. So you may want to enable Express updates as kind of the last thing you do on a Friday afternoon and hope that it finishes downloading all that stuff by the time you get back in on Monday morning.
Okay.
Sorry, just a couple of questions. One, what port does Branch Cache use, and does it conflict with anything else?
What was the question? Oh, what are the ports?
Yeah, what port?
The ports used for branch cache are actually in the firewall rules, and now I've forgotten what they are, but the delivery optimization port, I think it's 7830 branch cache. I don't remember what port it's using, but they shouldn't conflict with anything else.
And the other question...
I take that back. Branch cache uses port 80 by default. So with the branch cache configuration, it becomes a question of who comes first. If you've got a web server running on your machine that starts up on port 80, branch cache then isn't going to be able to use port 80, and it's not going to be able to function on that particular PC. It is possible to change the port that's used for branch cache to something else. Branch cache doesn't really care what port is being used. It can still discover other peers regardless of what port they're running on, as it just sends out a broadcast over a well-known discovery protocol. So you could change it to something other than port 80, but branch cache does use 80 by default. Config Manager, I don't remember what port it uses, but it is a non-standard port that should be well out of the way. So delivery optimization should be good. Config Manager should be good. Branch cache, you might want to push it to something other than 80.
And sorry, my second question is, when it starts downloading in Branch Cache, say it's downloading from a laptop and someone switches off the laptop, how does it recover from that?
In the case of branch cache, it's by chunk. So it's chunking up the data into something like 64K chunks. The size is actually variable, but if it errored out on the first chunk, it's just going to send out another broadcast and ask, where can I get this chunk instead? If no client responds back, then it goes back to the server. But it's going to do that for every single chunk that it's trying to get from the server. So even if there's one chunk that it couldn't find on a particular client on its current subnet, it's going to continue to ask for all the other chunks. So at some point, it may be able to find a client that has those. So it's pretty resilient to any outages or PCs that come and go. It's just a question of, is there at least one PC that I can get to that will respond to me with the client, with the content that I want?
Hi there. I've got a question around the deploying of the Windows 10 image across all distribution points. So you've touched around CBB, so it's like every 4 months you get the new version. So just recently I've created a Windows 8.1 image, deployed it to 180 sites, and it took me a week. So doing that every 4 months, so that would mean I have to wait for a week to deploy a new image each time. So the question is there a way to actually optimize that distribution of the image to all distribution points, like the way how you discuss about branch cache? Can you do that on each and every distribution point, so that, let's say, up north, I already had like 20 sites deployed, can they actually just share around and then follow that same logic, so that the deployment will be a lot quicker?
If you're talking about config manager distribution points, generally not. That the config manager site servers need to get the content onto each distribution point themselves. Now, they do allow you to specify where that content should be pulled from. So if you have a hierarchy of servers, you can configure the rules that say this set of servers should pull the content from this machine should pull it from the central location. So you can do fan-out distribution like that of the content. It's still going to be subject to the slowest link that you have out there. You can help out some with the binary delta replication that's available in Config Manager. So, like, let's say we have a new Windows 10 release, you deploy it initially, and then 4 months later we declare that it's CBB, but we refresh the image that's going to be deployed. So WSUS sees a new version of that. You download a new 3.5 gig, and then Config Manager needs to distribute it. In that case, it would be smart enough to figure out what's the actual delta between the original image and the new image, and just redistribute the parts that have changed. What we've seen most of the time with those binary delta transfers is maybe it's 500 meg instead of 3.5 gig being transferred. It's not going to be a trivial amount, but it's much smaller than the full 3.5 gig.
Yeah, you mentioned the impact on the client with storage. In the new SCCM branch and using the peer-to-peer distribution, is there any documentation on the impact on any other impacts on the client? I probably got lots of naysayers out there in the organisation who would say, I don't want my client to join into this solution.
Yeah, and I think that's one of the reasons why it's still in preview with Config Manager, is they still want to provide those types of controls. So as just a contrast, look at delivery optimization. Delivery optimization allows any client to pull from a peer, but it will only offer itself up as a peer if it meets the minimum hardware requirements. The minimum hardware requirements are 4 gig of RAM and something like a certain CPU speed requirement and a certain minimum disk space requirement. I forget what the other two values are, but if you don't meet those, the client will never share content. On the Config Manager side, you have the ability to designate PCs as super peers. So those super peers are the ones that are considered to be beefy enough to provide content to other clients. If you wanted to, you could do that by targeting machines that meet certain minimum requirements. Like if you've got laptops out there, or even desktop PCs with 5400 RPM hard drives, they probably aren't a really good candidate for peer-to-peer sharing, because every time they offer that content, the person using that PC is going to feel the impact of that hitting their hard drive. But if they've got an SSD, they probably aren't even going to notice that, yes, there's a little bit of extra activity, a little bit of extra CPU, a little bit of extra network traffic, but it's not going to impact how they're using their PC. So it's going to depend based on those types of criteria. Targeting just the SSD-based machines as super peers is probably a good way of addressing those types of challenges.
With Windows 7, I understand they're going to have cumulative updates and eventually right back to the base version of Windows 7. When is that likely to occur?
Well, we started with the roll-ups this month. So we did the first one on Patch Tuesday a week or so ago. That started the roll-ups growing over time. We expect to start adding older updates into that probably sometime early next year, maybe in the February timeframe, and then continuing to add batches of them in each month so that over time that cumulative roll-up grows to include all of the post-SP1 updates that we've released completely. We think that it'll peak out somewhere in the 500, 600, 700 meg range by the time it gets to that point. We will continue to offer a security-only update that's not cumulative every month for those that are worried about those sizes getting too out of hand. So you can deploy the security-only update every month and then periodically deploy the roll-up to pick up the non-security fixes. But we do expect that to happen probably over about a year from the point where we start doing that.
So in about a year's time, you'd
Yeah, and the nice thing about that is over time that gets us to the point where we've eliminated a lot of the patch fragmentation on Windows 7, and it gets us to the point where at least as we approach Windows 7 end of life, we've got all the PCs at a reasonably stable level. Now we tell all the customers that it's time to move from Windows 7 to Windows 10 because end of life for Windows 7 is January 2020, which is about 3 years and 3 months away. That seems like a long time, but for organizations that do that via hardware replacement and they do a 3-year hardware replacement, they're running out of time to get started on that. For orgs that do 4-year replacement, they're already well within that 4-year range, so they've got some challenges. So we know some percentage of customers probably won't finish that migration from Windows 7 to Windows 10 before January 2020. So we want to get those PCs to that baseline point with all the updates applied to it, because we know that they're going to then come to us and want to sign custom support agreements to continue support on Windows 10 after that, and we want to do that from a very stable, consistent patch state, which is the big push to get all of that into the roll-up update before that point.
all right, thanks.
I think we are over time now, so if there are any other questions, come up front. Otherwise, thanks for attending.